Hello everyone and welcome back to our channel, and today's video we'll be talking about the convergence of a series. But before going directly to the convergence of the series, we'll have first some review of the convergence of a sequence. Let me start first with the important points that we should remember regarding the convergence and divergence of a sequence and a series. I have here two important points for the convergence of a sequence. It says a sequence converges if it is approaching some finite number called the limit. In other words, if there exists a limit in a given sequence, then we can say that the sequence is convergent, or the sequence converges to that limit letter L. But if a sequence does not approach any number, or the limit does not exist, then the sequence is a divergent one. So to remember, you must only remember that if the limit exists in a given sequence, then the sequence is convergent. But if the limit does not exist, or the sequence does not approach any number as it goes to infinity, then the sequence is a divergent one. Okay? When it comes to a series, the definition says that if a sequence or the sum of the nth term converges to the limit, which is called S because this is the sum, then the series is said to converge to S. In other words, in a given series, if the sum of the terms converges to a sum, we call that S, the sum, as the limit of the given series. And the sum of the terms is equal also to that limit, or in other words, that limit is the sum or the S. If the sequence of partial sums diverges, however, then the series is said to diverge also. A divergent series has no sum. Okay. In simple language, it means that if an infinite sum add up to something finite, or if the limit exists, we say that the series converges. While if an infinite sum or the series does not add up to something finite, then the series diverges. Two important points to remember: if the limit exists, the series is convergent. If the limit does not exist, then the series is divergent. Let me have an example. We'll start with example number 1. It says, determine the convergence or divergence of the following sequence. Our first example here is given a sequence in a closed form, and this is 1 plus 2n over n, as n starts with 1 to positive infinity. Question is, we'll determine if this given sequence is divergent or convergent. Okay? The first thing that you should do is to write this one in open form. So we will write this one in open form. And to write a sequence in an open form, we must only substitute the values of n to n and then simplify. So if we'll simplify the given sequence, this will be equal to, the first term will be 1 plus 2 times 1 all over 1. Okay, and take note, a sequence is having commas, but a series have a plus sign. So this time we have a comma to represent the first term and to separate the second term from the first term. Okay, the second term will be 1 plus 2 times 2 over 2. If you'll be asking where did I get this 1 here and the denominator 1, I only change n to 1 because it says the condition starts with 1 up to infinity. Okay, so the third term will be 1 plus 2 times 3, obviously, over 3, and so on. Okay, so we will simplify. 2 times 1 is 2, 2 plus 1 is 3. 3 over 1 is 3. I will not write any more 1 as the denominator. Okay, and then 2 times 2 is 4. 4 plus 1 is 5. The denominator is 2. And 2 times 3 is 6. 6 plus 1 is 7. 7 over 3 is 7/3. Okay, and this sequence will continue because our upper limit in the given problem is infinity. So that is the open form. If we will continue the process, let's say for example, if n is equal to, let's say, 50, what will be the 50th term? Okay, so if n is equal to 50, this sequence will be equal to 1 plus 2 times 50 over 50, which is equal to 2 times 50 is 100. 100 plus 1 is 101 over 50. 101 divided by 50 is 2 point something. Okay, 2 point something. It seems that when we allow bigger values for the value of n, let's say 1,000, 10,000, 1 million, 1 billion, it seems that it is approaching number 2. So in other words, by writing the given sequence in open form, we can say that it is approaching a finite number, and that number is number 2. Okay, so to get that limit, because we say that it approaches a single number, which is number 2, we will find now the limit of the sequence, which is the limit of 1 plus 2 over n as n approaches infinity. Let's find the limit. In advanced algebra, you know how to find the limit. The basic technique is to substitute the value of n to n and simplify. But as of this time, we cannot substitute directly infinity to n because it will be infinity over infinity. So the technique here is to simplify. So this will be the limit as n goes to infinity will be equal to 1 over n plus 2n over n, which is equal to the limit as n goes to infinity of 1 over n plus 2. I have cancelled out the 2 n's there. So what is the limit of 1 over n? The limit of 1 over n is 0, and then plus 2 is equal to 2. Maybe you'll be asking why the limit of 1 over n is 0. Okay? Think of n as a big number. For example, the limit as n goes to infinity of 1 over n is equal to 1 over a big number. So, when we have 1 over a big number, let's say 1 over 1 million, what's the answer? 0.00001, right? Okay. How about if I will let 1 over 1 billion? 0.00009 zeros, 0.0000001, and so on. So in other words, if we will divide 1 by a big number, the value or the answer is approaching 0. So in other words, 1 over n as n goes to infinity, if you'll find the limit of that, the answer is 0. Okay, and 0 plus 2 is equal to number 2. So this one, this value, number 2, is the limit of the sequence 1 plus 2n over n. Since the limit exists, we can have now our conclusion. So I will write here the conclusion. Okay. Since the limit, which is equal to 2, exists, therefore, the given sequence, in which the sequence is 1 plus 2n over n, is convergent. Okay? Remember, if the limit exists or the sequence will approach a specific number as n goes to infinity, then we can say that the sequence is convergent. So in other words, the given sequence, the first example that we have here, is a convergent sequence 1 plus 2n over n. Okay, let's have another example. In the second example, I have here another sequence. It is represented by 1 plus negative 1 raised to n, as n starts with 1 up to positive infinity. Same question that we will be asking. We will determine if the given sequence is convergent or divergent. And how do we prove that a given sequence is convergent or divergent? The first thing that we should do is to find the limit. But it will help if we will write first this one in open form. Or in other words, we will expand the given sequence so that we can understand the behavior of the terms of the given sequence. So if I will substitute 1 to n, this will be equal to 1 plus negative 1 raised to 1. I will start with the exponent 1 because n here started with 1. Okay? And the next term will be 1 plus negative 1 squared. And then 1 plus negative 1 cubed. And 1 plus negative 1 to the fourth. And so on. Okay? So, we will simplify. Negative 1 raised to 1, that is negative 1. Negative 1 plus 1, that will become 0. Okay, negative 1 squared, that is negative 1 times negative 1, that is positive 1, plus 1, the answer is 2. Okay, next term, negative 1 times negative 1 times negative 1, and the answer is negative 1. Okay, we'll multiply negative 1 3 times, and the answer is still negative 1. Plus 1, the answer is 0. The fourth term, negative 1 raised to 4, that is positive 1. That's right. Positive 1 plus 1, the answer is 2. If we'll continue that negative 1 raised to 5, that is an odd number, the answer is negative 1. Plus 1 is 0. It seems that our terms here in the given sequence is bouncing back between 0 and 2. So, what will be your observation? It does not approach any specific number because it is bouncing back between 0 and 2. So, if the behavior of the terms of the given sequence is bouncing back between two numbers, in our case or in example number 2, our value as n goes to infinity is between 0 and 2, then do you think the limit exists? No. The limit, we can say here that the limit does not exist. Okay? And if the limit does not exist, what will be our conclusion? Okay, so we can say here that since the limit does not exist, therefore, the sequence, the given sequence 1 plus negative 1 raised to n, as n started with 1 to infinity, is divergent. Okay, so you see in example number 1, the limit exists and we say that the given sequence is convergent, while here in number 2, the limit does not exist because as we go along with the terms of the given sequence, it is bouncing back between values 0 and 2. So the limit does not exist. Since the limit does not exist, we can say that the given sequence is divergent. Okay, I hope you understand now the convergence of a sequence. Okay, now if we'll move on to series, series is different because we are finding the sum of the terms. Now, for example, determine the convergence and divergence of the given series. And for example, our given series here is, let's say, the summation. Okay, I will write this one as the summation because in a given series, it is understood that we will add up the terms. So I have here the summation of 3 over 10 raised to k, as k started from 1 to 3. Take note that is in this given series we have the lower limit and the upper limit, so we will only write this one up to 3 terms, or k equal to 3. So this will be equivalent to 3 over 10 raised to 1. I will start with 1 because k started with 1. Okay, take note this time we will have a plus sign because we are talking now of a series and not a sequence. Okay, 3 over 10 squared plus 3 over 10 cubed. Do we need to stop now? Yes, we need to stop now because our upper limit here in the given series is 3. So we substituted now 3 to our k and we need to stop now. So the open form of this one will be 3 over 10, okay, plus 3 over 10 squared is 100, plus 3 over 10 cubed is 1000. Okay, so this is now what we call the open form of the given series. If we will write this one in decimals, this will be equal to 3 divided by 10. That will be 0. What? 0.03. Okay, plus 3 divided by 100. There are 2 zeros, so that will be 0.003 plus 0. We have here 3 zeros, so 0.0003. Okay, so if the given series has an upper limit, you need to stop. Okay, but for example, the given series have no upper limit. Let's say we will rewrite the given, I will change the color. We will write the given series here as like this one. Let's say as k from 1 to infinity of 3 over 10 raised to k, then our sum of the terms will be different. This will be 0.03 plus 0.003 plus 0.0003 plus blah 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 until such time that we will approach infinity, because our upper limit here is positive infinity. So there is no limit of substituting the values of k, or we will raise 10 raised to k as k approaches infinity. Okay, so if we will add this one, what will be the sum? Do you have any calculator there? 0.03 plus 0.003 plus 0.0003. Okay, it seems that it will add to 1/3, right? It will add to 1/3. And in other words, as we go along with our terms, the terms will become smaller and smaller because we keep on adding zeros here, and it will approach 1/3. This 1/3 now is what we call the limit of the given series. Take note, the given series. So since the limit exists, we can say this time with our conclusion that since the limit exists, which is equal to 1/3 exists, therefore the series given by 3 over 10 raised to k, as k will start from 1 to infinity, is convergent. Okay, as simple as that. As long as you can say that there is a limit or the limit exists, then it is automatic you will say that the given series is convergent. Take note, in a series we're adding the sum of the terms. in a sequence. We're just examining what is the behavior of the term. Okay, so let's have another example. How about this series given by this closed form 2k as k start from 1 to infinity? What will be the open form of this? So this will be 2 times 1. I will substitute 1 to k because here k started with 1, plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5 plus other terms. Okay? And this will be equal to 2 plus 4 plus 6 plus 8 plus 10. What do you think is the next term? Okay, 2, 4, 6, 8, 10. It seems that this is a series of even numbers. Okay, but the behavior that we can see here is as we go along, as k goes to infinity, the value of the term is becoming bigger and bigger. Imagine if we will change k to 1 million, what will happen? That will be 2 times 1 million, that will be 2 million. How about if we will change this letter k here to 1 billion? 1 billion times 2 is 2 billion, right? So as k goes to infinity, do we approach any number? I will repeat the question. As we allow bigger values for k, let's say 1 million, 1 billion, 1 trillion, do we approach any specific number? The answer is no. We are not approaching any specific number, but we are approaching positive infinity, or in other words, as we allow bigger values for k, the value of each term is becoming bigger and bigger and bigger. So if this one approaches positive infinity, it means that the limit of this series does not exist. So since the limit of the given sequence does not exist, therefore, okay, we can say that therefore the series given by 2k as k starts from 1 to infinity is divergent. Okay, so I think you have now a very good retention of an idea when to say that a given series is convergent or divergent. Very simple. Just remember, if the limit exists in a given series, it means that the series is convergent. But if the limit does not exist, or the limit of the sum of the terms does not approach any specific number, then we say that the given series is divergent. Thank you very much. That's all for this time, and in the next video we'll be talking more about special series. Thank you very much and see you soon.